ElixirconfAfrica. I'm very happy to present on this virtual stage. Let me introduce myself. My name is Michal Slaski. I live in Krakow. In this talk, I will talk about our recent experiences in using Elixir, Livebook, and Livebook apps. So a few words about myself. I can code in at least one programming language. I'm raising at least one child. And I tried teaching at least one school subject. If you are a programmer, or a parent, or a teacher, I hope you will find some inspiration here. So my motivation started around 2017 when Poland, my home country, introduced compulsory programming classes from the first grade of primary school, which in Poland starts at the age of 7. At present, not all the countries go as far as teaching programming from the first grade, but most recognize the importance of so-called computational thinking and teach it at schools at some point. Nowadays, when many national curriculums include computing, the hot topic actively debated is what makes the computing pedagogy effective. In our experience, the computing pedagogy needs to consider age, because if we want to teach computing at the early years of primary school, we need to make these classes engaging. Also, if our ambition is to teach so-called computational thinking, which includes algorithmic thinking, abstraction, decomposition, evaluation, logic, generalizing, and so on, we need to consider how skills, understanding, and memory are constructed in human brains. I started my teaching practice with children aged 6 and 7. Computers or tablets are not necessary when teaching children at this age. Actually, electronic devices are often a source of distraction, and they don't necessarily help. Children enjoy developing their social skills. Well, who doesn't? They start to relate themselves to their peers. A group of researchers from the University of Canterbury in New Zealand exploited it and created classes where children play active roles. The project is known as Computer Science Unplugged. It shows binary systems, sorting, encoding, decoding, protocols, and many more computer science concepts. For example, one of the classes demonstrates how sorting networks work. In this diagram, numbers which we want to sort are traveling from the right to the left. In each circle, there's an intersection of two paths where we need to compare two numbers. When the two numbers meet in a circle, the lower number goes left and the higher number goes right. No matter in what order numbers start on the right, they always end up sorted on the left. Now, you may wonder, how can children play roles in this scenario? Let me show you. Here we have 4 numbers on the right. From the top, these are 3, 4, 2, 1. The game starts. And at the end, we see sorted numbers from 1 to 4. Teaching computer science unplugged for 3 years to different classes was an eye-opening experience for me. I was in shock when I saw a class of 9-year-olds who managed to design a communication protocol. It had splitting payloads into packets, packets ordering, packet loss discovery, and even lost packet retransmission. All of this was created within 45 minutes, which is a single class unit in Polish schools. The protocol resembles some characteristics of TCP/IP, and it allowed transmitting messages in a noisy environment. It had really good quality and accuracy. So these experiences led me to establish a teaching practice under the name Coderki, where our aim is to teach abstractions by making. When designing a logo for Coderki, we had an opportunity to hide a message which programming language we aim to teach, and this opportunity has not been missed. Right, so for example, how do we teach recursion, which is an important concept, both in maths and in functional programming? How do we explain recursion in an engaging way? Well, trees grow in patterns. In maths, a fractal is defined using recursion. We can grow a fractal tree. This kitty, named Jovita after the first Polish female programmer, is growing a fractal tree in the picture. We used a simple recursive algorithm to generate fractal trees and let our students play with it. They could experiment on their own with the number of iterations, randomness, and other parameters, which would result in quite realistic trees, similar to those created by Mother Nature. We then continued to explore patterns used by the Mother Nature, experimented with real plants, used some artistic techniques to copy the patterns from plants to textiles. And to make it a memorable experience, we used a technique of press printing. Every girl in our class made a custom backpack with a fractal tree. Here we go. They took the fractal tree backpacks home, and we see them every once in a while walking down the streets of Kraków. We continued to search for effective teaching methods over the years. I have already shown some successes we had with groups aged 7 to 9 with Computer Science Unplugged. I also discussed our experiences of working with groups aged 10 to 11 with the artistic makings. Now, let's focus on the age of 12. I used to chair the program committee of Lambda Days conference, and this is where I came across the Bootstrap project created by researchers at the Brown University in the United States. The Bootstrap project uses functional programming to teach subjects such as algebra, data science, and physics. They developed a very rigorous and engaging content. They approached it with truly scientific spirit. Their content was evaluated with scientific methods, and they published a lot of academic papers and presented at various conferences. It was a great inspiration for me. In Polish schools, on the subject of mathematics, students learn about numbers, algebra, sets, functions, geometry, probability, logic, and a few other topics. Inspired by the Bootstrap project, we started to think about ways to exploit what students already know and what they intuitively understand. We created a map of maths which can help with mapping of math concepts to programming concepts. We took the Polish national curriculum, tried to identify topics like expressions, equations, geometry, composition, and so on. And then used Elixir and Livebook to illustrate where these concepts can be used in computing. The use of math concepts in functional programming can be nicely illustrated with Elixir. Let me show you some examples. This is a photo of a Polish textbook. Those next few examples are taken from the Polish 6th grade math textbook. Such textbooks are used by students at the age of 12. This first example illustrates algebraic expressions. If we take this one, we can very easily translate it into Elixir Livebook cell. And believe me, this is a very joyful experience for students to play around with Livebook cells and Livebook expressions. Another example from the same textbook. Let me read it for you. Eva said to Oleg, think some random number, multiply it by 5, subtract 5 from the result, then subtract 3 times the number thought at the beginning, and finally add 15. Final result was 18. So what was the number that Oleg thought about? So we can translate this composition of operations into a nice function composition in Elixir, where we have the same sequence of operations with the final result being 18. One more example from the same textbook. Here the instruction is to note down algebraic expressions that represent perimeters and areas of the geometric figures. Students know the formulas, so we can note them down as simple functions. Perimeter of a triangle given x, y, and z is the total of the 3. And again, giving this pattern from the textbook translated to Elixir cell is a lot of joy. When mapping math concepts to computing, the functional paradigm is very handy because its foundations are built on mathematics. It is not to say that other programming paradigms are not useful, but some of them, like imperative programming or procedural programming, resemble the architecture of processors and machines that execute the program. When we teach computing with an imperative language, we first need to introduce new abstractions and teach patterns that are further away from math concepts. At schools, we already teach a lot of patterns that are close to functional programming. We teach substituting a value into a variable and then evaluating an expression. We teach definitions of geometric functions like area of a square or perimeter of a triangle. We teach set theory, which is not far from data structures. We can also teach other programming concepts like recursive function or pattern matching. There is just one more piece missing. We learn effectively when we have intrinsic motivation to learn something. If children are driven by their own interests rather than imposed convention, their learning can be much more effective. So, we invited students to develop an outdoor game of Hare and Hounds. The game is also known as a paper chase. The game has a number of riddles. Solving one riddle leads to another riddle. Typically, one group is creating the riddles and hiding them somewhere, and the second group is chasing them by following the riddles. In this sketch, we have a map of the school building. We also have stations from 1 to 9, where the riddles were hidden. Now, let me show you how some of those stations were designed. For example, this one requires finding out some number. Once you got the correct number, you can open a cache. Inside the cache, we find a QR code, which takes us to the next riddle. The next riddle is deployed as an Livebook app. Livebook apps have been introduced in a recent release of Livebook. They allow us to deploy interactive applications which are implemented using Elixir and Kino. So here I have a number of such apps already developed and deployed. Let's give a short demo. In the apps section of Livebook, you will see all links to deployed applications. Each one of them has been defined in a separate Livebook file. So if we go to the first one, this one reads too much, too little. It's a very simple game where you need to guess a number from 1 to 1000, but you only have 10 guesses to try. So here it says, type in a number from 1 to 1000. Let me type 500. Guessing. 500 is too much. You can still try 9 times. If this is too much, let me try 250. This is still too much. So I can keep going until I find the right number. When I find the right number, it also gives me a clue to solve the next riddle. So that's one Livebook app which we have deployed here. Let me show you another one. This one is about cipher, Caesar cipher. It's a very simple concept where you given a number, just shift letters of an alphabet by this offset. So if we have a message like ElixirconfAfrica and we want to shift it by 3, this is what we would get. And then we can try the same message in the opposite direction. ElixirconfAfrica. In the Polish alphabet we don't have the letter X, so this one was skipped, but otherwise it works fine. So again, this could be part of another riddle where, given the correct offset, we can find out what is the hidden message. Let's move on to one more example. This is yet another Livebook app which implements another kind of cipher. Hello there. Here we will need a key to encode and decode our message. Let's make it something simple like ABC. Now the same message that we got here can be decoded with the same key. Again, very simple operation, but can be a nice baseline for one of those riddle stations of the Hare and Hounds game. So Elixir and Livebook not only help us to explain some topics which are on the intersection of mathematics and computing, but also gave us another superpower, apps, a way to deploy what we have implemented and engage the whole. There are many ways to deploy Livebook and Livebook apps. We tried deploying it using a standard Livebook Docker file on the Google Cloud Run service. Cloud Run is a serverless offering from Google Cloud. In the Google Cloud Admin Console, we can set the request timeout for up to 60 minutes. So we effectively get an instance of Livebook which lasts more than a standard class unit of 45 minutes, and then it auto-destroys itself soon after. When configuring Cloud Run, we also need to set the maximum number of instances to 1 to ensure that subsequent requests hit the same Elixir node. And then we can also set the Livebook apps path environment variable to automatically start all Livebook apps. That's all I have prepared for today. I will be happy to engage in a discussion or answer any questions that our audience may have. Thank you.
Someone has a question and they're asking, what kind of ongoing support or resources are available for parents and teachers who want to continue teaching functional programming to kids after your program or workshop?
All right, that's a very nice question. Just to confirm, can you hear me all good?
Yes.
All right, good. Thanks very much for the question again. Right, so all the materials that I presented here or mentioned in the slides and during the talk are all open source. They are all available online, either Computer Science Unplugged and Bootstrapped projects. Those are the university materials which were developed over the many years. All of them are public. Also, the Livebook apps I presented here are open source and published on our GitHub account. I can tweet the links later after the presentation. So frankly, my advice would be just get started wherever you feel like, be it the Computer Science Unplugged classes or be it something more sophisticated like the Bootstrap environment, where they have designed their own functional language for all the classes, or just use Elixir as I have presented in my experience, using some of those Livebook I have shared here, or developing your own simple Livebook cells. I think the most important part is to just get started. Once you get started, you see how children engage, what works well, what doesn't work, what does not keep them engaged. You will fine-tune your behavior and what is it that you will continue doing, what is it that you will stop doing. My experience when talking to parents or teachers is that sometimes we try to prepare too much to get started. The important part is to make the first step, and then there are so many open source materials online that you will have no problem finding more inspiration. I hope that this answers your question. If not, please refine the question.
Yes, that, I guess, answers the question quite correctly. So there's another question. The question being, the reason I am, sorry, what do you think of this debate? The functional languages should be taught as first languages. Do you understand my question?
Yes. So I think the question is concerning that in most classes, most schools around the world right now, the first language that the children get a chance to try are typically either block languages like Scratch or some imperative languages like Python. And the question is, should we teach a functional language like maybe Elixir or other functional languages as the first programming language? So this is a question I've been asking myself for many years. And I tried to teach different languages as the first language. I tried Scratch, I tried Python, I tried Elixir. And my experience is that, like I tried to explain in the presentation, the mathematical foundations that all children are getting familiar with over the years in primary school and secondary school, they are very helpful when you need to explain some computing concepts. So without like extra effort, extra hassle to explain new paradigms, new concepts, new abstractions dedicated to computing, you can easily just take your mathematical concepts, even like textbook examples I gave from the regular math textbook, and directly translate them to functional language code and see how it executes, how it computes some value. So my own experience here is that functional language was an easier experience for me as a teacher to introduce children to computing. Now, I don't claim myself to be an expert on the subject, and there are so many different practices around the world on teaching computing, and probably every teacher would have their own experience and observations. So I'm sharing my own experiences in a hope that some people may find it inspirational, but I'm not trying to make a claim that that's the way we should teach everybody. Probably the practice of teaching is quite a complex matter anyway. So it's not only about which language you pick, but also many other factors that impact how effectively we learn new concepts. So I think it's not only about which language you will pick as the first one. But again, to address your question, I strongly believe functional languages have a place in our curriculums.
The last question is, what are some of the advantages of using functional programming over object-oriented when teaching kids programming?
So before I move to answering that question, I think I would like to highlight another aspect of teaching first. What I found to be the most important part is the interaction that a child may have with the computer when practicing, when trying things out. What I mean here is that rather than typing in some program in an editor and then trying to compile it and then trying to execute it and then seeing the output, which takes several steps to actually see some feedback of what my action resulted in, what was very helpful is to have an interactive Livebook experience. There are some other coding notebooks technologies available, which one can use to introduce computing concepts. So Livebook is not the only option, but a Livebook-like experience is definitely helpful because the immediate feedback that a child gets when they type in some expression and then evaluate expression and they see the result, this is what helps enormously with engagement, and it encourages experimentation. And when we are learning some new concepts, experimentation is very useful to see yourself what it means, like build your own understanding of the concept, build your own connections, what my actions result in. So anyway, so I would, again, first focus on the right tooling, which gives this immediate feedback like Livebook does. And then the second sort of question is, so which language do we want to teach? I have also very good experience in teaching Python using Google Colab or Jupyter Notebook. Those are similar to Livebook interactive notebook technologies. So again, if anyone has access to those and would like to give them a try, I think it's a good option. What I do like about Livebook is an open source technology, very easy to deploy in a variety of devices and cloud environments. So I found it also very practical to use this both offline in the classroom and online when deployed in the cloud. Not all notebook technologies allow such flexibility in terms of deployment and using it offline and so on. So for this reason, I find the combination of Elixir and Livebook like a perfect match for the school classroom.
Was this worth your time? Hope so. Please subscribe to stay in the loop for more of this content. In case of any queries or suggestions, feel free to hit us up on Twitter. We'd like to extend a warm welcome to ElixirconFAfrica2024. And here's the best part about this one. It'll be an in-person event. What a good excuse to come to Kenya. Again, we're super grateful for helping make this a success and definitely looking forward to seeing you in the next one. Cheers!